Okay. In this lecture, we're going to go over a quick run through of the whole process of writing some smart contract programs using the Remix browser-based smart contract editor, writing them in the Solidity language and putting them online and interacting with them in the Ropsten test network. We'll go into detail in later lectures on more of the concepts and how to do Solidity programming, but here the goal is just going to be to get all the way through from the beginning to the end. Now, last time we talked about using MetaMask, and we went through some examples of sending transactions to and from different addresses on the test network. So we basically thought of the blockchain as something just storing account records. But now the idea is that we're looking at smart contracts. The accounts can now be running programs that have some code and storage, and you can interact with them by sending data as well as money. All right, so it's the same blockchain as before, except now we're looking at putting accounts that represent running computer programs defined by code. Now we're going to look at using the Remix editor to write smart contract programs in Solidity. And all you need to know about Solidity for now is that it's a programming language that's a bit like JavaScript. You can think of it as a kind of object-oriented programming. If you're familiar with other object-oriented programming languages, the idea is each contract is defined by a contract class. Right? The contract programs you write are like classes. And just like objects of a class, they can define member variables that are basically persistent storage, and they can also define methods, and the methods of the object have access to read and modify the member variables of objects of that class. All right, and so smart contract programming is really defining such classes and setting them up. All right, so on to the demo. What I'm going to do is load up the Ethereum browser at remix.ethereum.org. Now, I'll wait for, don't know what to do about that little error that pops up, but it's not so important. We'll just ignore it for now. This thing gets, modified and maintained periodically. Anyway, once it's there, I can look around. I have a list of files that are open. When you open this for the first time, you might have some starter files. They start you with like Ballet or balletsample.sol. You can delete and rename and add new files to this, just like a file browser. I'm going to be starting by defining this hello world Solidity file, .sol or Solidity files. You can see these different tabs. I can close the tabs. All right, let me zoom in a bit so you can see the language here a little better. All right, I'm going to leave auto-compile on. You might want to turn this, if you turn it off, then you actually have to hit the compile button deliberately each time you modify the code and compile it. If you do auto-compile, it'll compile it every time you stop editing. All right, so I have one smart contract class, some contract class tests defined in this file. Right now it doesn't have any member variables or functions. I'm going to, let's see, maybe we'll give this a counter to, it starts at 0, and we'll modify that. Let me define one function. I'm just going to have one function for now. This is going to be my hello world function. I want this function to be publicly callable because I'm going to go put it on the public testnet and interact with it there. I'm going to have it actually return the hello world string. So I need to say that it returns something and say what that is. In order for this to compile, I need to have, let's see here. All right, public goes there. It's going to compile now, but give me a warning. If I go read the warnings here, it says I can be more strict about the state mutability. Basically, I can also put pure here, which means that it doesn't modify any of the member variables. And I'm going to have it return the constant string hello world. There we go. I need a semicolon at the end of the string, at the end of the line. Oh, and that keyword should have been return, not returns. There it goes. So this compiled without any warnings. Now, to interact with this contract, I'm going to look at the Run tab here. Now, there's two ways that we can do this. One of them involves, oh boy. Okay, back to the right view. Okay, we have two options of how to run a smart contract from the Remix IDE. One of them is to go straight to the public test network. This involves using your browser-based wallet MetaMask. It actually uses the MetaMask plugin. If we click Injected Web3, then this is going to be deploying the contract using this test network account I have in MetaMask. You can also use this JavaScript VM. This just runs a local simulated Ethereum network in your browser. It doesn't involve any interaction with the outside world. So typically you want to start by running your programs in the JavaScript VM and then later run them on the actual test network. So I'll show you once really quickly of both of these options. So here in the Run tab, because I've successfully compiled this file that I have open, I get to see all of the smart contract classes defined. I only have one of them. It's test with a capital T, so that's the contract I'm going to create. Now, if I click the Deploy button, and I look down at this little sub-tab Deployed Contracts, I'll see one instance of this contract, and it's running in memory. That's because I'm running in the JavaScript virtual machine environment. Now, if I expand this little drop-down window, probably really should move this, move it over like this. No, that doesn't do it. There, that might be better. When I look at this, when I click on this contract in the deployed contract section here, I see that it has one method test. And when I click on test, it's blue indicating that it's a pure function. And when I click on that, I get the string hello world back. All right. Let's see. I want to show off the ability to do member variables here. So before putting it on testnet, I'm also going to add a couple more features. I'm going to add a public string message, which is initially I'm going to leave it not even defined yet. See, should be string public message. There we go. Oh, I don't want to. I want to have this be better. Message like that. Okay. Now I'm going to define a new method that actually modifies. I'm going to make a new method that modifies this string. So I will simply do it set. This set will take in a string parameter, m, and I will simply assign message to whatever is that, that message there. Now, let's see. I need to set my settings for that. Okay, this now compiles without any warning. Okay, and I can do this again in the JavaScript virtual machine. When I click deploy here, I get an instance of this contract in memory. If I look in the deployed contracts bin of this tab, I see this one object. And when I look at this object now, I now see three methods. The getter method for message, the test pure method that I defined earlier that still returns hello world. When I click message, it's an empty string because that's what the member variable message was set to. And now I've got this read method, which is a mutable method. And if I put a string here, I will actually be able to set the value of this. So I'm going to set it to hello again, world. Now, when I click this, it's actually going to send this as a transaction in the built-in JavaScript virtual machine. So to actually make this string pass, I need to give it quotes. When I put quotes around it and this succeeds, I actually see the transaction show up in this little console panel here. If I expand it, I get to see some more details about the transaction, that it was that it succeeded, how much gas it consumed, more details about it like that. And now, because I ran this method, it succeeded. If I go click on the pure method, the getter for message again, I will see that now it says hello again world. So this has been modified, and now when I query the current state of this member variable, I get the updated value. Okay, so I've tried this contract out once, not a very thorough test, but I've tried it at least once. Now we're going to put it on the live test network. So I'm going to switch the environment from JavaScript virtual machine to Injected Web 3. It's going to be using my MetaMask. And I'm going to go make a deployment of this contract on the test network. So when I hit deploy, it pops up a request to use my test account to create an instance of this contract on the test network. Now this, I need to click to confirm this. I'll just go ahead and click to confirm it. I get options to change things like gas fee. This is going to cost the equivalent of 7 cents of testnet ether. I'll simply hit confirm. And let's see what it says about this transaction. Okay, so now in the deployed contracts bin, it actually shows me a blockchain contract rather than an in-memory contract. But it still has the same interface as the one that I created locally. I have the set method here. I can look at the current value of message, the current value of test. And if I go to set the contract here, actually first, let's go look at this contract in Etherscan. So if I copy the address of this on blockchain contract and go to ropsten.etherscan and give this contract address in the URL, I will see that, okay, here's this contract that was created 60 seconds ago. Now, if I want, let's see. If I want Etherscan to be able to interpret the contract, I actually have to go and copy and paste my code here. So I'm going to do this so that we can view it in Etherscan, although you don't necessarily need to do this, and it takes a little bit of time, so we won't do this in every case. Oops. Okay, so I'm going to copy this code. I'm going to check that I know what version of the compiler I'm using. I'm going to paste this code into the verified source code on Etherscan tool. The name of the contract is test. This is the version of the compiler I was using, and I had optimization turned off. All those conditions have to match. It's a little bit tedious. Oh boy. This goes on forever. How much work do I have to do? All right, they must have a lot of trouble with spam to make me go through that many steps. Okay, that worked. So now Ethereum Etherscan knows all about the code for my contract. So now when I go to the contracts page, I can read all the member variables of the contract. See, so now even Etherscan, when it shows me read contract, it shows that I have the message member variable, I have the test pure function. And I can even use Etherscan as another way to generate transactions. So if I were to try to modify it here versus modifying it in Ethereum, those are two ways of sending a transaction. So I'll do one and then the other. So first I'll do it through Etherscan's write contract feature. So I'll do hello world 1. Now this should pop up another request through MetaMask. Let's see what I get here. No, it doesn't seem to be integrating with MetaMask the way I want. All right, let's do the alternative. Okay, so back to the Run tab. I want to modify the, I want to send a transaction to this contract on Etherscan that modifies the string member variable to our new message. So we're going to do hello world. Click set. This pops open a MetaMask window prompting me to approve this transaction. It's going to take 1 cent in gas fees. Okay. All right, now this is giving me a link that I can click that'll take me directly to this transaction as seen in Etherscan. Now right now, just as before, I am waiting for I am waiting for this transaction to be committed, but the transaction has now been committed, so it shows up in the little console view of the Remix editor. If I view this transaction in Ropsten, on the Ropsten Etherscan, it also shows me a view of this transaction. You can see that this transaction was calling the set string method, and this is the rest of that data. Right, if I click decode, it shows me that it recognizes it as setting the argument M had the value hello world in capital letters. And now if I refresh this view of the contract and I look at the read contract tab, it shows me the current state of the member variable message of this contract is to the value that we set it to. So whether you're looking at it at any of these Etherscan views or through the Remix browser, through the Remix Deployed Contracts tab, you'll be able to see and interact with your contract and see the transactions and the effects that they had. Okay, that's all for now, and next time we'll talk in a little bit more detail about what kinds of more complicated smart contracts we can make.